This is Mr. Beck Does Your Homework, AP Physics, Homework 9.2, question number 11. It says two charges are located on a horizontal axis. There's one of them, there's the other one. Determine the electric field at P, this point, on a vertical axis as shown in the figure, where up is positive. The Coulomb constant is, answer in units of volts per meter. Well, I've got this charge and this charge. Luckily, I've got the same distance. Hopefully you do too. So this is 3 meters, this is 3 meters, this is 1.8 meters. So I know that this charge will create an electric field in this location pointed at some angle up that way. But since this is symmetric, I know that this charge is going to do the same thing up that way. So what I'm going to wind up with is, at that point, I'm going to have an electric field in this direction and an electric field in this direction. Well, this one is made up of this vector and this vector. This one is going to have an x component and a y component. So what I see is that the x components are going to cancel each other out since they're equal and opposite, since it's all symmetrical. But my y components are going to add together. So really, if I just analyze one of them and find the y component of this field, then I can double them and I will get both y components. So now there are a couple things I need to know. What is my r going to be? Well, my r is going to be the square root of a squared plus b squared. So for me, it's going to be the square root of 3 squared plus 1.8 squared. So that'll give me my r. That's the distance from here to point P, because I need to know that for the r. So now I could figure out my electric field strength is going to be K times the amount of that charge, just this one, 1.4 times 10 to the minus 6th, divided by r squared. Well, r squared is going to bring me back to this, isn't it? So r is going to be 3 squared plus 1.8 squared. So you can shortcut that without actually having to square root if you so choose. Once I get the E field, now I only want the y component of that E field. To get the y component of the E field, well, I'm going to have to do something like a sine or tangent or something to figure out that angle. And once I figure out that angle, I know that the y component is going to be E times the sine of theta. So E is going to be my electric field strength up at the angle times the sine of theta will give me my electric field strength pointing in my vertical direction. And then I know that since I've got two of them, I need to take that whole thing and double it. Now, there's probably a nice, simple mathematical way to get rid of some of this because the sine is opposite over the hypotenuse, but maybe you can do something with a tangent and relate it to 3 and 1.8 and get some magic answer that doesn't even matter in terms of all of this. So I just want the y component of that, so you might be smart and figure out another way, but this will certainly work. So find your r, E is kq over r squared, then draw your triangle, figure out that angle theta. So I've got my point where my charge is, I've got my origin, I've got my point P. That makes a triangle, so I can figure out this theta, so I can figure out the sine of the angle and do E sine theta, giving me my y component. Part 2 says find the vertical component of the electric force on a negative 2.4 microcoulomb charge placed at point P. Well, since it's all y components, since the x components cancel out, all I've got to do for that one is just going to be F equals Q times E. And that E is this that you just answered in question number 11.